Good morning, class.
Morning, sir.
So at this point, we're busy with differential calculus. You guys have homework?
No.
Sure. Okay, so I'm going to look at last year's calculus question that came in the June exam. Is that okay? And none of you actually bothered looking at the sum, so I'm going to take it off. Makes you sad, but okay. I'll pause the video at this point and cut last year's question. Okay, so this was one of last year's questions. Question 3. So at this point, the question was for 15 marks. I'm going to give you 8 to 10 minutes to sort this out as far as you can. If you're done before that as a group, please let me know. Then I will do it straight on the board, okay? So I'll give you a couple of minutes. Again, I'll pause the video at this point. Alright, so the first question was to evaluate. You got the limit as x approaches 2 of x minus 2 over x cubed minus 8. So to apply the limit here, let's put your past paper. Okay, so we have the limit as x approaches 2. So what we need to do is we need to factorize the denominator. As you know, if I substitute 2 into that equation, we'll have a denominator of 0. Okay, so we need to factorize this denominator here. Of course, x minus 2 is one of the factors. So it's going to be x squared plus 2x plus 4. So of course that cancels. If I see an x, I put the 2. So 2 squared plus 2 times 2 plus 4, which is 12. So it's 1 over 12. Okay. The next question. Next question reads, you must apply first principles. Okay. So to apply first principles then, we know we need to use the formula. So importantly, I write down the formula. F prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. If it says by first principle or by definition, this is what I do. Okay. So if f of x is equal to negative x squared plus 2x, then f of x plus h is equal to negative x plus h squared plus 2 into x plus h. Okay? So I write here the limit. I don't drop the limit until I substitute 0. That will give us negative x squared minus 2xh minus h squared plus 2x plus 2h minus h squared plus 2x plus 2h minus, in brackets, negative x squared plus 2x. And that's all over h. If I multiply the negative out, I'll get positive x squared, which cancels the negative x squared. You get negative 2x, which cancels out positive 2x. So what I've noted at this point is that we have a common factor of h. At times you could have had more than h that was a common factor. But I won't take it out. Why? Because if we take it out, we must multiply it in again. Okay, so that h is cancelled. If I see h, I put the 0. The answer is negative 2x plus 2. Once I substitute that 0 in for h, I drop the limit. Okay? And we can check. We can check if it's correct. If we apply that rule, that differentiation by rules, you can check f prime x equals, that's going to give you negative 2x plus 2. But if you do this, in this question, you don't even get 1 out of 5 marks for that question. Okay? So the question says explicitly from first principles. Okay? Let's look at number 3. Number 3 says determine d of x. If d of x is 5x squared minus 2 over x plus 6. So I can apply my derivative. Now I can't apply my derivative because of this here. Not so. I'll take it up. Which now gives me 5x squared minus 2x minus 1 plus 6. Can I apply my derivative as it stands here? Yes. Why? Because it's in the form of ax to the exponent n. So apply the derivative, it then gives us 10x minus plus 2x to the minus 1, 2, and the derivative of a constant is 0. The question did not say with positive exponents, but I know many of you like writing it with positive exponents. So 10x plus 2 over x squared. Remember that negative only applies to the x. Okay. Number 3.4. We need to first get rid of the brackets. So y is equal to 3 root x times 3 root x is 3x. 3 root x times negative 3 is negative 9 root x. Negative 1 times x is negative root x plus 3 all over x. So I'm going to add like terms. So it's 3x minus 9x minus negative root x minus root x is negative 10 root x, which is 10x to the half plus 3 all over x. At this point I put each one of its own. So it's 3 minus 10 x to the exponent of minus 1 is negative half plus 3 over x, which becomes 3x to the negative 1. And as you can see here, it is in the form of ax to the exponent n. So in this case I can apply my differentiation by the rules of differentiation. So that will simply be dy over dx equals, the derivative of a constant is 0. Negative 10 times negative half is 5, x minus 1 is negative 3 over 2. 3 times negative 1 is negative 3x, minus 1 is minus 2. Again, you don't have to apply this here. But I know, as I said, some of you like writing with positive exponents. So that's 5 over x to the 3 over 2 minus 3 over x squared. And that there I can write in radical form. That is basically x to the 1 and a half. That 1 is on the outside, x to the half is going to be the root of x minus 3 over x squared. Okay? Any confusion here? No? Let's look at number 4. The sum is worth 22 marks, so I can't give you 22 minutes, so I give you 15 minutes. It's the graph question. You see, this graph question comes in for quite a bit of marks. Can you see that? 22 marks. And yesterday I said 15. Huh? How many marks did I say yesterday? But it varies, man. It depends on what questions the examiner asks. It's not always 22 marks, or not always 15 or 8 marks, whatever. It depends on the questions the examiner puts out at that point. I'm going to give you 15 minutes. Né? As I said, I can't give you a full. "22 minutes. Again, I'm going to pause the video at this point. Can you all see, no? It's clear. Alright, so in question 4, we are given f of x equal to x cubed plus 4x squared minus 3x minus 18. In 4.1, if f of 2 is equal to 0, determine the x-intercepts. So if f of 2 is equal to 0, that means to say that x minus 2 is a factor. Not so. So it's a factor of f of x. So which means to say 0 is equal to, for the x-intercept, let y equal to 0, x minus 2 into. You get x cubed, x times x squared is x cubed, negative 2 times what is negative 18? It's positive 9. Alright, so that's going to give us negative 2x squared. What must be added to negative 2x squared to get an answer of 4x squared? So what must be added? 6x squared. So 6x squared divided by x is positive 6x. So as you can see, we've got the perfect square trinomial there. So it's x plus 3 squared, or x plus 3 times x plus 3. So therefore, x is equal to 2, or x is equal to minus 3. You see as a 2-in-1 solution. Okay, it will bounce off on the x-axis at that point. Okay. In 4.2, this is 4.1. This is 4.1. So x is equal to minus 2 and x is equal to 3. Minus 3. Okay. In 4.2, determine the coordinates of the stationary points. So what are stationary points? Turning points. How do you work out the turning point? First derivative, which is 3x squared plus 8x minus 3, and I said equal to 0. I drop that. So I can either use a quadratic formula, or I can factorize a trinomial, or I can use a calculator. But this can factorize easily. So it's going to be 3x times 3 is 9, minus 1 is 8. The bigger one is positive, and that's negative. You all agree with that? So x is equal to a third, or x is equal to minus 3. Okay. Have you answered the question? No. They want the coordinates. So you work out f of a third. So wherever you see an x, you put a third. So it's going to be 1 over 3, so it's the third cubed, plus 4 answer squared, minus 3 answer, minus 18. You negative 500 over 27. Negative 500 over 27. So in other words, the one coordinate is a third, and negative 500 over 27. On the other end, you've got f of minus 3. You put negative 3 in the calculator now. Equals. So that's the last answer calculated. Sub that into the formula. Gives you an answer of 0. But we should have known that coming from that 2-in-1 solution. But say we didn't know. Okay. So the other turning point, of course, is going to be negative 3 and 0. So I'm going to write it here. There's 1 over 3 and negative 500 over 0 over 27. And the other one is negative 3 and 0. This is your minimum value. Local minimum. And that's, of course, your local maximum. Okay. In 4.3, Determine the x value of the point of inflection. Hence discuss the change in concavity that takes place. So how do you work out the point of inflection? Second derivative, not so. So you apply the second derivative. Remember the first derivative was 3x squared plus 8x minus 3. So your second derivative will be 6x plus 8. And I said that equal to 0. So x equal to negative 4 over 3. So now we say f of negative, they only want the x value. If the question was for the coordinates of the points of inflection, then I would have substituted negative 4 into the original equation. Then I would have gotten the corresponding y value. Okay? So it says discuss the concavity of the graph, so it's to do with concave up and concave down. As you see that is positive, so the graph goes up and down. The point of inflection happens at that point. Okay? And the x value here is x is equal to negative 4 over 3. So what do we say x must be? Less than negative 4 over 3 for concave down. Okay? Or x must be more than negative 4 over 3 for the graph being concave. Okay. Let's take us out here. In 4.3, they ask you to sketch the function and indicate all intercept. What intercept didn't I work out at this point? Your y-intercept. Can you see that? I must still work out my y-intercept and the point of inflection. Do you want that also? And the point of inflection. So in other words, I needed to have calculated the corresponding y value. Okay? And just work it out. What was the x value of the point of inflection? It was negative 4 over 3. Is that correct? Yes. Negative 4 over 3. The corresponding y value for the point of inflection is negative 250 over 27. So we'll come back to that now. So what was my x values on this graph? Sorry? 2 and negative 3. No? Then the turning points happened at negative 3 is 1, negative 3 and 0, and a third. It's close to the x-axis. And at the third it's turning at? This goes up and down. So it's going to be a third and negative 500 over 26. Okay, from the turning points I draw my graph. And what is my y-intercept on this graph? At x equal to 0, which is negative 18. Okay, so that is that point there. The point of inflection occurs midway between the 2 points, which was negative 4 over 3 and negative 250 over 27. Can you see that, people? Let's go to the next question quickly. 4.5. 4.5 says, for which values of x the function decreasing? This part of the graph increasing or decreasing? Increasing. So the graph is then decreasing for x is greater than negative 3 but less than a third. So it's x is greater than, so it's a continuous solution. X is greater than negative 3 but less than a third. 4.5. 600. Determine the equation of the tangent at x equal to 2. So that is that point there. Not so the tangent is going to be drawn in line. The tangent is a graph that is a line that cuts above 1 point only. So y is equal to mx plus c. To calculate m, it's your first derivative at 2. Can you see that? What was our first derivative? 3x squared plus 8x, not so? Minus 3. So that's going to give you 12 plus 16. So it's 3 times 2 squared plus 16 minus 3. That gives me 25. So my gradient, as you can see this graph has a steep gradient which confirms that as well, it's 25. It's going to have a very low y-intercept here, as you can see. So the gradient of this graph is 25. So y is equal to 25x plus c. The only point that we know that's lying on the graph is 2 and 0. If I didn't know the corresponding y value, I would have substituted 2 into the original equation. So 0 is equal to 25 times 2 plus c, which is 50. So c is negative 50. The equation is y is equal to 25x minus 50. Then it says, another question pertaining this could be, just close here, just give me a minute. The next question could be, determine the value for x for which the tangent cuts the graph again. You see what happens is, that's what we have, not so, and the tangent line there. Sorry, it's a straight line there. But this line goes all the way down here. And that, so this tangent will cut the graph again at some point. Not so. To work out that we then set the equation of the tangent equal to f of x. And then we will get that answer that you're looking for at that point. Okay. And then the last question, 4.7. We are told if p of x is equal to f of x plus k, for which value or values of k will p have 2 distinct positive roots and 1 negative. So basically what happens here is that p of x is a f of x which is shifted horizontally. So as it stands here, what you notice, there's 2 in 1 negative and 1 positive. Can you see that? But here we want to know, for that f of x function, that's now this graph here, for which values, so the shifting is the k. When I move up or down, I'm moving up or down according to the k value. Can you see that? So it says here, we'll have 2 distinct means different positive roots and 1 negative. Currently, we have 1 positive, 1 negative, 2 in 1 there. There's 2 negative, 1 positive. Can you see that? 2 negative, 1 positive, 2 negative, 1 positive, up until here. Can you see that? But they want 2 positive roots. So you must go a bit higher than that. Can you see that? Here we got 2 positive roots there. 1 there, and 1 there. Can you see that? So, how many units did it move up to get to this point already? They just at that point of 0, it moved up how many units? Well, it's cutting here at 18. So I moved up how many units? 18 units. Not so. Then you move up. By how many units now? It will stop there. Can you see that? Which is to do again with this turning point here. Can you see that? So it's to do with 18 and, so k has to be greater than 18 but less than 527. Okay. And why 527? Because that negative 527 has to move all the way up for that to touch at that point there. Can you see? For it to have 2 positive and 1 negative. Okay. People, that's that. Enjoy the rest of the day and the weekend. All the best with the exam. Okay.